Okay, hello everybody. Welcome to Set International School Online. Okay, this is mathematics class, and today we're going to be looking at statistics. Statistics, that's our topic for today. I believe that at one point in time in primary school, you have done you've come across statistics before, you know, on the basic level. You've come across statistics before. So, but today I'm going to go a step further. Okay. So I'll take it further, and this topic is going to take us 3 weeks to cover, but I'm just going to lay the foundation today. I'm going to be laying the foundation. I will define terms that you're going to come across while doing solving problems of statistics. So we're going to explain different terms and terminologies today. Then from next week we'll go into our calculations properly, and then upper week we're going to round up on the topic. So today I want to go and start with the definition of statistics. So what is statistics? Statistics is concerned with the collection of data, their description, and their analysis, which often leads to the drawing of conclusions. So in other words, to summarize the definition, statistics simply means the science of collecting, describing, and interpreting data. I'm going to go over that again. Statistics can be defined as the science of collecting, describing, and interpreting data. So there are two major areas of statistics. Look at that. You have the descriptive statistics and you have the inferential statistics. Those are the two broad divisions of statistics. So let's go to the descriptive statistics. This talks about collection, presentation, and description of sample data. How about the inferential statistics? That talks about making decisions and drawing conclusions about populations. So the first one, that's the descriptive statistics, talks about the collection, the presentation, and the description of sample data. Then your inferential statistics talks about making decisions and drawing conclusions about populations. We are going to be making use of all of this from next week. I'll just lay the foundation like I said today. So let me introduce you to some basic terms that we use in statistics. Now we have number one is population. This is a collection or set of individuals or objects or events whose properties are to be analyzed. For example, you want to analyze the population of students in a class or in a school. You want to tell whether these numbers are from the northern part of Nigeria, or are from the eastern part of the country, or these numbers are from the western part of the country. You may want to analyze based on where they come from, their tribes. You may also want to analyze based on their height. But the population, the individuals, the set or the group or the collection that you want to analyze is your population. That's what you want to analyze. The set of individuals or objects or events whose properties you want to analyze, that forms your population. Then there are two kinds of population. We have the finite population and you have your infinite. Okay, so let's go to the next term that I want to talk about. That's your sample. That's a subset, a portion of the population, a subset of the population. Sometimes you want to analyze a portion, just a portion out of the entire population. That's your sample. So let's go to the next term. The next term I want to talk about, that's variable. This talks about a characteristic about each individual element of a population or a sample. By the time we begin to go into calculations, now all of these terms will make sense to you. We begin to use them. So this talks about a characteristic about each individual element of a population or sample. Then another term there is data. Your data that you want to work with. We have two there that you can see. As you can see, this is the singular and this is the plural, because in mathematics, data, the plural of data is also called data. So I'll just explain the singular for us. That says the value of the variable associated with one element of a population or sample. This value may be a number, it may be a word, or a symbol. Then you have the plural form of the plural version of the data. It's just talking about the set of values. You know, here I said the value, and this place it says the set of values. That's more than one, collected for the variable from each of the elements belonging to their sample. So another term talks about experiments. This is a planned activity whose results yield a set of data. That is an activity you carry out, you know, to get some certain results. An activity you carry out that the results will yield a set of data for you. You are going to need the results. You know, you will make decisions based on the results. So that's experiment. Then you have parameter. Parameter is talking about a numerical value summarizing all the data of an entire population. That's your parameter there. Then statistic. Statistic is a numerical value summarizing the sample data. Let's just go and see some example. Let's take one example that will help me to make use of all those terms so that you can begin to digest it. It will make sense to you now as I use it in an example now. All those terminologies I've mentioned, all those terms, as I make use of them now, it will make sense to you. Now look at this. And the major example we want to use, look at this. A college dean. A college here is talking about universities. Some countries like United States, they call their own universities college. So it's talking about higher institution, tertiary institution. Yeah. So there in the university you have faculties like a sub. It's bigger than a department. How do I explain this now? You have the entire university. Then the entire university is divided into faculties. You have faculty of education, faculty of art, faculty of science, faculty of social science. So you can now have different departments under different faculties again. So but the head of a faculty is usually called a dean. It's called a dean. They call them dean, the head of a faculty. So here they say a college dean is interested in learning about the average age of faculty. That's the average age of members of the faculty. Of course, you know that a faculty will comprise of students, it will comprise of staff, teaching staff and non-teaching staff, you know. So a faculty dean, the college dean is interested in learning about the average age of faculty. Look at this. Identify the basic terms in this situation. So let's look at that. I'm going to make use of all those terms I've explained earlier on using this example. So the population is the age of all faculty members at the college. Does that make sense to you now? The population, if you want to analyze the average age of a faculty, you will need to get the population. You need to get the age of all faculty members at that college. So the age of all faculty member is your population. That's what you are working with. That's the end. You get the entire age. Put it down. You get everybody's age. Put it on ground. Then a sample is any subset of that population. For example, we might select 10 faculty members and determine their age. For example, if we don't want to look at the age of everybody, we can just pick at random, pick 10 people and ask them, what's your own age? How old are you? This one tells me it's 25. I write it down. How old are you? So you can pick 10 faculty members and determine their age. You use them as sample. That's a subset, a portion of the entire. So you can still make decisions based on that sample. Do you understand now? So let's go. The variable is the age of each faculty member because it's not going to be the same. Everybody can have the same age. Did you see that? So the variable is the age of each faculty member. Then one data would be the age of a specific faculty member. That is one person's age is one data. One data. because we need it's 1 plus 1. If it's one each person, so that you put together, that will form the entire population. But 1 out of the whole stuff is a data, 1 data. So it will be the age of a specific faculty member. Then the data would be the set of values in the sample. That is the plural version. Now it will be the set, like the total value, the set of values in the sample. Okay, the experiment in this example I'm using now, the experiment will be the method that you use to select the ages. The method used to select the ages, forming the sample and determining the actual age of each faculty member in the sample. Then the parameter of interest is the average age of all faculty at the college. Then the statistic is the average age for all faculty in the sample. So let's proceed from that. I hope with that example now you have idea of all those terms as I've explained them earlier on. So let's go to variables. Now we have 2 major kinds of variables. We have 2 kinds of variables. We have the qualitative or attributes or categorical variable. That sounds cumbersome, but it's all the same thing. The qualitative variable can also be called attribute variable. You can also call it categorical variable. It's just good you have all those names, so that anytime you come across it, if a textbook or a question decides to use categorical, you will not be confused. It's all talking about qualitative variables. So mostly it is referred to as qualitative variable and quantitative variable. But qualitative variable is also the same as attributes or categorical. Those are other names you can call qualitative variable, while quantitative variable can also be called numerical variable. So let me go back now and explain qualitative variable, which is also categorical variable or your attribute variable. This is a variable that categorizes or describes an element of a population. Note, under qualitative variable, you do arithmetic operations such as addition and averaging are not meaningful for data resulting from qualitative variable. I am going to give you examples of qualitative variable below, because it's just talking about, it's just like things describing something. So you are not going to be counting there, like colors, describing maybe the height of something or color of something. You are not going to be calculating or adding or subtracting or doing averaging, that kind of scenario, because it's just talking about describing. It's just this type of variable just is talking about the attributes. You know, it's talking about attributes, talks more about attributes, and or categorizes something under a particular feature. So it's a qualitative variable. Then the next one that is quantitative is the one that deals with numbers. That's why it's also called numerical variable. So this is a variable that quantifies an element of a population. Note, arithmetic operations such as addition and averaging are meaningful for data resulting from a quantitative variable. Now, let's go and take examples of a quantitative variable. Then I'll also show you examples of qualitative variable. Remember, I told you qualitative is talking about attributes, quantitative is talking about numbers. So just let that sink into your minds, because as time goes on, you will need that information. Qualitative talks about attributes, characteristics or features that something has. Then quantitative talks about numbers, so you will need to count. The other one talks about features or attributes. All right, examples of quantitative data. Number 1 is number of TV sets owned by a family. Did you see that is talking about numbers, and you will count in this scenario? Now, number of TV sets owned by a family, this can be counted. It's quantitative, it's numerical data. So another one is number of books in the library. That's another example of a quantitative data. That's the number of books in the library. It can be counted. You can decide to count the number of books in the library. It's It's possible for you to count it. So it's a quantitative data. It's a numerical data. Let's go. The time spent on travel to school, like from your house, the number of minutes, the time you spend to move from your home to school, or from wherever you are coming from to school. You can calculate this. It's not, you will have numbers from this, I'm very sure. So this is quantitative. It can be counted. You can get the number. You can get figures for this. So it's an example of a quantitative data. Another one is the amount of rainfall. Yes, it can be measured. So this is also a quantitative data. Then the weight of an apple, it can be measured. It deals with numbers. It's a quantitative data. The weight of an apple can be measured using a scale. Amount of rainfall can also be measured. So it's a quantitative data. Let's go to examples of qualitative data. I have them here. Examples of qualitative data. You recall that I said qualitative data does not deal with counting. It talks about attributes. Features. So look at this. Eye color. You cannot count it. You can only describe it. Gender. You can only be male or female. You can't be counting. It's not something to be counted. It's something to just describe. Each time you have columns asking you to tell gender, do you have to write number 3 there or 5? No, you will only say whether you are male or you are female. So it's talking about attributes. It's not talking about numbers there. Then you have the color of an apple. It's an attribute. So you can categorize apple under green apples or red apples. That is why we call it qualitative data or categorical data. So you can categorize an apple under a green apple or a red apple. Look at this. The taste of an apple. So that talks about attributes. It's not something you want to be counting. The taste of an apple is not something to count or number. It's something that will tell you, just describe. The smell of an apple too is a qualitative data. I hope that explains better to you. So I'm going to just take one example here. And then I will skip because of time. Identify each of the following examples as attributes. So you will tell me whether it is attributes, you identify it as attributes, that is qualitative data variable, or whether it's numerical or quantitative variables. Does that make sense? Is that clear to us? You want to identify each of the following examples as attributes, that is qualitative. You will tell whether it's a qualitative variable or it's a quantitative variable. Let me do number 1 for you. The residence hall for each student in a statistics class. The residence hall for each student in a statistics class. That is where students live. That's hostel. Indirectly, it can be counted. You can count. So this is quantitative variable. So I'm going to move away from that. And go to the next one. Okay, there are still more questions for us here, as you can see. So all of this, we are going to do them on our own. Let me move forward from there. Okay, so to my next slide, I have qualitative and quantitative variables may be further subdivided. Look at this diagram. Just gives us the further division of qualitative and quantitative. As you can see, the major one here is your variable. The variable is majorly divided into 2. Like I told you earlier, variable is majorly divided into qualitative variable, which is also the same thing as attribute variable or categorical variable. Then it's also divided into quantitative variable, which is the same as your numerical variable. Now you can proceed further to divide your qualitative variable into nominal and ordinal variable, while your quantitative variable can also be divided into discrete and continuous variable. I'm going to explain the nominal variable, the ordinal variable, the discrete variable, and the continuous variable one by one, and I'll tell you how to recognize each of them when you are solving questions. Number 1 is the nominal variable. This is a qualitative variable. You remember? we got this subdivision from qualitative variable. Okay, so this is a qualitative variable that categorizes or describes or names an element of a population. It categorizes an element of a population. So we'll come back to that. I'm going to use it as an example for you. Then ordinal variable. This is a qualitative variable. It's also still under your qualitative variable. It incorporates an ordered position or ranking. This is the one that tells you the position of something, the ranking of a variable, whether something is in the first position or third position or fourth position. That's your ordinal variable. Then you have your discrete variable. Of course, you know that this is produced from your quantitative variable. Quantitative variable is divided into discrete variable and continuous variable. So from your from this place now, you have, this is a quantitative variable that assume a countable number of values. Intuitively, a discrete variable can assume values corresponding to isolated points along a line interval. That is, there is a gap between any two values. I'm just going to explain this later on. I'll come back to that to summarize it. Then, continuous variable is a quantitative variable that can assume an uncountable number of values. Intuitively, a continuous variable can assume any value along a line interval, including every possible value between any two values. Okay, now let me go further. So statistics deals with numbers. You need to know that the nature of numbers that you have collected. So one, let's look at the continuous variable again. Continuous variable talks about the types of number associated with measuring or weighing any value in a continuous interval of measurement. Examples: weight of students, height of plants, time to flowering. All of this will require measurement. So anything that will, I'm still going to summarize how you'll be able to differentiate continuous variable, discrete variable, ordinal variable, nominal. I'm going to do a summary for you now after I have taken all of this. So you see, continuous variable, the major thing that will help you to differentiate continuous variable is that it deals with measurement. You are either measuring something or weighing something. Do you understand now? So that is, it deals with measurement. That's your continuous variable. While your discrete variables tells you the type of numbers that are counted or categorical, like number of boys, number of girls in a class, number of girls in a school, number of insects in a house, number of plants in a place. You will have to count. This one deals with counting. It deals with counting. Discrete variables talks about counting. Continuous variable talks about measuring or weighing. You see that is one major thing you can use to differentiate the two. All right, so note, in many cases, a discrete and continuous variable may be distinguished by determining, that is, the major thing you will use to differentiate a discrete variable from a continuous variable is by determining whether the variables are related to a count or a measurement. Whether it is related to a count or a measurement. If it has to do with counting, you know that it is discrete variable. If it has to do with measurement, then you know it is continuous variable. Don't forget, that is a major factor you will use to distinguish the two. The discrete variables is related to counting, while the continuous variable has to do it with measurement or weighing. Let's continue. So that's just what is repeated here. Discrete variables are usually associated with counting. So I just go to number 3. It says continuous variables are usually associated with measurements. Did you see that? They are usually associated with measurements. Now, I'm going to run over all that I have said now about the discrete variable, the continuous variable, and the ordinal variable and the nominal, because I'm going to be using these examples now to explain the four. The nominal variable describes, it categorizes. Your ordinal variable tells you the ranking or the position. I told you that earlier, whether it is the first position or the third position or the fifth position. Your discrete variable always refers to counting. It's always something you will have to count. The number of girls, the number of books in a library, the number of workers on a site, the number of students in a school, the number of teachers in a local government, you will always have to count. That's your discrete variable. While your continuous variable will always point to measurement, something you have to measure or probably weigh. So that's your continuous variable. Don't forget, this one talks about description, something that talks about attribute you will describe. This one talks about ranking or position. This one talks about your counting. You can see my cursor where I'm pointing it. Your nominal variable talks about the categorizing of something into maybe attributes. Your ordinal variable talks about the ranking. That's the ordered position, like first, second position. Your discrete variable talks about anything that will require you counting. Number of stones, number of books, number of pencils. This one now, that's the discrete variable. Then your continuous variable basically talks about measurement. Anything that will require measurement or weighing is a continuous variable. I believe that is clear to us. So I'm just going to use example 1 here to explain further to you so that you have idea of what I am saying. The length of time. Identify each of the following as examples of nominal, ordinal, discrete, or continuous variables. That is, they want you to tell if these stuffs are, you will tell which one is nominal variable, which one is ordinal variable, which one is discrete, which one is continuous variables. I believe that is clear enough. Okay, so the first one here, I have the length of time until a pain reliever begins to work. The length of time until a pain reliever begins to work. Of course, it's not talking about position. It's not talking about something that is describing something, and it's not counting anything. It's something that we have to measure. We have to measure. We have to measure. So that is a continuous variable that you have there. All right. So I'm going to move away from that. I believe with that example, we are able to get what that means. Okay. So I'm going to proceed to data collection. First problem, data collection. The first problem a statistician faces is how to obtain the data. That's the first problem every statistician faces, how to obtain the data. So it is important to obtain good or representative data because inferences are made based on statistics obtained from the data. What does that mean? When the government wants to get the population of students in a particular local government, they are not just doing it for fun. Most times it's because they want to make decisions, and so they need to gather the data first. They need to have information that they are going to work with. They need the data that they are going to work with. So inferences are made. That's why data has to be representative and good. What you have written down, the data that you have gathered or collected must be good and something that is dependable. That's what you mean there by representative. So because decisions will be made based on the statistics obtained from the data. So it also means that inferences can only be as good as the data. That is, if the data is not correct, the inferences cannot be correct. What does that mean? If government decides to find out how many children of 10 years and below are living in the whole of Mushin, and they say, okay, can you get us the data? If the investigator has not done a good job, and instead of recording 30,000 children are less than 10 years old in Mushin, if he has done a lazy job by recording that there are 15,000 children that are less than 10 years old in Mushin, the local government chairman will only make decision based on the 15,000 that was recorded. Perhaps he wants to provide a laptop for each of those children. It will only make provision for 15,000 because that was what was provided. That was the data that was provided Whereas the total number of children that are less than 10 years old in Mushin local government are actually 30,000 children. I just use that as an example. So did you now see that decisions or inferences can only be as good as the data? If the data is not correct, the inferences or decisions made based on that data cannot be correct. So that's what that means. Let's look at the process of data collection. Process of data collection. Number one, you define the objectives of the survey or the experiment. You define what do we want to achieve, what do I want to achieve by this survey or experiment. Then an example of that is to estimate the average life of an electronic component. Then number two, you define the variable and the population of interest. Then you define the data collection and the data measuring schemes. This includes sampling procedures, sample size, and the data measuring device. That is the device you decide to use, the method, the scheme you want to use to gather your data. You can use questionnaire, you may have to measure like using scale, you may have to measure using ruler. So those are your data collection or data measuring schemes. Then you need to determine the appropriate descriptive or inferential data analysis techniques. We need to determine that too. So we just move forward to methods used to collect data. You can use experiments. In this case, the investigator controls or modifies the environment and observes the effect on the variable under study. That is, you adjust, you twist it this way, see the outcome you will get. You can modify it again and see the outcome that you also get. So the investigator can control or modify the environment and observe the effect on the variable under the study. That is for experiment. That's for experiment. Okay, let's proceed. Another method you can use to collect data is survey. Data are obtained by sampling some of the population of interest. The investigator does not modify the environment. Okay, let's go to census. Census is a 100% survey. It's a survey of all the members of a population. So it says 100% survey. It's every element of the population is listed. Every element of the population is listed. That is why it is not commonly used, because it is difficult and time consuming to compile, and it is also expensive. All right, like I said, we are going to conclude this lesson in 3 weeks time. So from next week, we are going to go into our calculations. We are going to start with our calculations from next week. All right, so till I come your way next time, stay blessed, stay safe, bye.